We're back today with the chart for your nonlinear sine wave electric capacitor, resistor, induction fuse, and connector type coding simplified in a format. And then in H2, when you get your binary, use H2 commands writing a computer. So let's look at, if you were to use capacitors and resistors in your circuit boards or in any electronic drawing, you want to keep a log. I showed you the sim waves in the other video. So what you want to do is you want to have them at their peak voltages, voltage, average voltage efficiency, and we'll look at that right now. So here's the formulas. You're going to know the gain, the effective, the appetite, the wavelength, the directivity, the field strength, half wave up to 30 megahertz above wave, the wavelength, your resistance, wave line, averages. Your average voltage is 6.36. Your effective current is 6.36. Your max current is 0.7. Max voltage is 1.41. So in between these numbers is where you get your battery charges up to in about 707 and 637 in the average, and then it has a harder time climbing up. And the battery, when you're using a battery, like after 707, it's harder to build up every time. So we have our power, voltage ratios, current ratios, and decibels, pulse width, pulse repetitive time, repetition programs, and other things. So what we're going to do here is there's a system to writing resistors and capacitors. This one has your cable strength. Okay, they're designated in color pencils. They have a designated number, different color. You write the application signal, you side identification in the color designator. You use your you pick a side. Let's see, is this upside down? No, it's not. All right, so when you do this, you're gonna wanna pick your ruler, and when you get your sim wave, which there's several different bands. So we're using the sliding ruler. You'll mark it here, here, and here, and here. Write the numbers down. So you write number 1, number 2, number 3, number 4, like on that, where you got it on the bottom scale. That keeps a record of your recorded electronic RCL, or whichever one you want to do, RCL, right? So then in here, I'll teach you the capacitors. The capacitors are not always made out of gold. They're made out of lots of different materials. You have your first, second digit multiplier and tolerance. These come in color bands. And then, let's see, oops, I just ripped that page. Time required for 63.2%. And voltage, 36.8, time constant growth and decay. That goes about charging. You have a time constant growth and decay, about 63.2%. It gets harder for the battery to charge. Okay, a resistor is noted like this. We have a capacitor, resistor, induction coil, or sometimes they're just square for both resistor and capacitor. So when you have a resistor on this side, RC separates the voltage growth and decay on both sides. So what we're doing is we're taking this symbol right here, and we're marking the sin voltages in the book. So we have our resistor. Whatever sin wave was on the last video, we'll trace on this one. We'll take a voltage efficiency, the upper, lower bands, voltage required for the charge, so there is no dissipation in between the RC circuits, okay? And it will be in a model envelope. Puts them all together. So what we're doing here is you're gonna wanna have a 3-step system. 3 different rulers, you mark them out, you track the sin voltage in the middle line, you keep your record from when I first used the marker, and on the bottom of the scale, you write that on your notebook, which would be like 2, 4, 5 bottom scale. You do then there's sin, sorry, I'm rushing myself. So you'd make this one the resistor LCR. And then, and this scale over here, there's one that goes in the circle, and it has, the inner scale has the sin in it. So we record the sin, we record this sin, we record this sin, we make a couple blank ones, photocopies of the ruler. We write down the identification code that I left on the bottom of the ruler, and then we fill out each resistor of the capacitor. So one more card, we'll just say this is that one is a resistor. This one's a capacitor because I separated the papers earlier. So we still have our band lengths, which are that way now for each one of them. And so here's what the deal is. All right, a capacitor and resistor also has a color band, and they're a little bit different. So the different color bands, we keep the code, we keep the resistors, we keep the code and the resistor in the book. Everybody does the same format. We can work together as a team, put these charts up in your electric NASA base or whatever you're doing for electrician, because if you follow a different system, you're gonna screw up and everybody's not gonna learn, okay? So what we have here is, say we had our resistor, this square thing on the schematic. We looked up the voltage. We look at the capacitor part number breakdown, and then we mark it also down. We move it in a sliding scale, and then you would take your resistor, put it in the side, and your fuse in the bottom line. So you'd have this over here, your resistor over here, your sliding scale sin, the wavelengths, you record them. So this is the capacitor. It shows you how to view the capacitor part numbers. So you're keeping track of all the capacitor part numbers by color and ribbon bands. And then this one's also a capacitor one. So keep these handy so you can keep the note on where, so you'll have the identity of the capacitor. And over here, all right, that's as quick as I can tell you.